Okay, I'm going to show some of the division strategies that we learned this week to help some of our students understand long division. The first problem that I'm going to solve is 24 divided by 3, and I decided to choose the repeated subtraction method and also a visual model at the same time here, which will show addition repeated too. So the visual model would say you add 1, 1, 1, 2, 2, all the way till you get 24 objects dealt or partitioned out, and it would show how many would be in each group. So I'm going to do the same thing, but with the repeated subtraction next to it. I'm going to pass out one object at a time, which uses up 3. So we have 3. I'm just going to continue this. Okay, I came with a remainder of 0, so it was a nice, I know 24 divided by 3 is 8. So I'm going to check that here. We have 1, 2, 3, 4, 5, 6, 7, 8 in each group. That's 8 plus 8 plus 8, which we know is 24. Repeated subtraction 1, 2, 3, 4, 5, 6, 7, 8. The next model that I'll show is moving on from this model to a little bit more of a difficult number to divide with. Is 231 divided by 3. This time it's not as reasonable to partition out one object at a time and draw each little individual dot in a picture, and subtracting 3 repeatedly from 2. This was already long enough, and so 231 would take forever. So a student might start to recognize that, hey, I could start passing out more objects at a time. So I'm going to take this same model idea, but instead of drawing individual dots to represent one object being taken out, I can look at, okay, 3 times 1 is going to take only 3 at a time, and if I do 3 times 10, that could take 30. I could get rid of 30. If I go 3 times 100, it would take 300, but they need to conceptualize that 300 is too many to take out, so 100 is not going to be reasonable. So we're going to get rid of this. We decided that 3 is just not really practical at this point, so we're just going to do 10 at a time to get 30 out. So 10, 10, 10. Instead of drawing 10 objects, I'm just going to put the number 10 in there. So I have 231 divided by 3, and this is called the Big 7 model. So I have 10 objects. That gets rid of 30. And I'm just going to play a little bit riskier, I guess I could say, but it's good for a student to be able to conceptualize this, that, hey, 10 is going to take me a little bit longer than I want to. So I'm going to just say, hey, let's guess 30 times 3 and get 30 out at a time, and that's 90, and that will get me down faster. So I'm going to say 30 objects. Just write that in the box to represent that I'm passing out 30 at 30 in each box. That's 90 objects. It gets me to 111. If I want to do 30 again, that's easy. And then now I have 21, which is a really good number. A really good number because it's a factor of 3. And I can say, oh, that's 7. Oops, I forgot to put the 30 up here for the second one. So kids need to remember to mark this down as they're going along. Probably won't do 2 models at the same time, but I'm showing them here. We have 7, 7, and 7, which is 21, 0. So I have 30, 60, 77. And so this should be 77. To check their answer, they can see 30, 60, 77 is in each group. I can check and see if 77 plus 77 plus 77 is 231, or 77 times 3 is 231. So that was a couple of models to show what to do when you're moving more advanced or to larger numbers. The next model that I'll show is the area model. And this is one that I learned in college, so I hope I can explain it okay. Here we go. If I have 231 divided by 23, I could do all of what I was doing before, but I'm going to show just a different method. In the area model, I have the area, and I have the width here and the length, and you multiply those to get the area. So that would mean the area divided by the width would be the length, and the area divided by the length would equal the width. So if I want to solve 231 divided by 23, I could use base 10 blocks and know that I'm taking 231 divided by 23. So I could show I need 23 as my width, and so I'm going to show that with base 10 blocks. 10, 20, 1, 2, well, lines and dots, I guess. So that's 23. And then when I was doing the area model with multiplication, I could represent this 231 as 2 hundredths and 30, and then there would be 1. This right here is a flat divided by a rod is a rod. See if this happens for everything. A rod divided by a unit is a rod divided by a unit is a rod, and a rod divided by a unit is a rod. So I know that this represents 230, and then there's a 1 remainder, because that 231 needs to be in that area box. So I have 10, a rod, which is 10 remainder 1. So let's just show that with the standard algorithm. 231 divided by 23. I know that 23 and 0, and it has a remainder of 1. So it's correct. It's a 10, a length of 10 with a remainder of 1. The next one that I will show is the box method, and so that was more for a visual learner. If they used this model to multiply in the beginning, you can use it to also divide. That's why I did that one. The box method is where I take, let's say I do 23, and I put a box here. This is another way of organizing the work, not necessarily a different way of doing it. I have 231 divided by 23. I know that 10 times 23 is 230. That results in a 1 remainder. I can't subtract another 23 out from here or any more, so this will be my remaining amount. I'll bring that up there. 10 remainder of 1. So those are the different methods that I decided to show today. I kind of explained when I would use each one, and I think it's important to note that there's different students in your classroom that learn in different ways, and you need to be open to using any of these methods and having them also just explore, different ways they would do it to come up with that algorithm that they'll learn in the end. So 231 divided by 23, they can start to conceptualize what that means. So that's it.